Alright, this is a video to instruct you on how to use direct variation. Direct variation is very similar to a slope-intercept form. The beauty is that the intercept is always 0. Y equals k times x, or a lot of times a times x, is the basic equation for direct variation. There's no more plus b, because you'll always, if you're graphing one of these, you're always going to end up starting from the origin. And from there, you just end up sloping according to k. K is what's known as the constant of variation. And the key to these problems is the first thing you need to do is find that constant so that then you can use your information to go and do more. So notice the example. Find y when x equals 5, given that when x equals 4, y equals 12. This second set of information is where you're going to find that constant of variation. So if y varies directly with x, then we can say that 12 is equal to k times 4. And k for us in this problem will be a 3. So we found that, and that's step 1. Step 2 is you want to usually write your direct variation equation. So y equals 3x will be our model. And now I can go back and say, well, hey, find y when x equals 5. So y equals 3 times 5, or y will be equal to 15, will be our final answer. Go ahead and use the information at the right and try doing those same steps to find the direct variation model and then find the answer to the problem. As you can see at the right, again, I just took the given information, plugged it in, found the constant to be -5/2, wrote the model, and then went ahead and plugged in x equals 8 in order to find that y is equal to -20. Hopefully that helps you understand how direct variation problems work. One other way that the book may make you approach them is sort of backwards. What if they give you a bunch of information and ask, is it direct variation or not? One thing you want to remember is that y equals a times x or k times x is your basic model form. But if we change that around a little bit and solve it for a equals y divided by x. If those coordinate points, y divided by x, always show the same a value, that same constant of variation, thus the word constant, then yes, it is a direct variation equation. So what we want to do is take all of our xy coordinates here at the bottom, all of our y's divided by our x's, and find out, do they give us the same number every time? So 20 divided by -5 is a -4. 8 divided by -2 is also -4. -16/4 is -4. And the model seems to be working for each and every one of our coordinate points. So if we divide all those out and we get the same thing every time, what we basically figured out is that a equals -4. And if you want to write the model, we can say that yes, it is, and y equals -4x would be our model. Now, on the other hand, if we take 2.4 divided by -5, which is a little bit tougher to do, but of course we've always got our calculator, we can go back here. 2.4 divided by -5 and find out that it's -0.48. And then I think we can pretty easily figure out that 4 divided by -3 is -1 1/3. Well, they're already coming out different. And we can even do one more real quick to find out that, yep, we're definitely getting different values every time. So no, this one is not a direct variation model. Finally, word problems for this kind of thing essentially always look the same. If you keep your eyes open when you read the problem, you'll always see somewhere in the problem where it will mention that you vary directly. So supply states that the quantity of an item will vary directly with the price of that item. So suppose for $4 per tape, 5 million cassette tapes can be supplied. Write an equation that relates the number C in millions of cassette tapes supplied to the price P in dollars of the tapes. Well, if the quantity supplied, the number of tapes, is directly related to the price, then we can say that C equals A times P. Then we can just take our given information that $4 per tape provides 5 million cassette tapes. So realize first thing we want to do is note that C is in millions, so we don't forget that later on. But we'll find out that A equals 5/4. So then we can go back and say, well, C equals 5/4 P, and we've got our model. Then determine how many cassette tapes will be supplied for $5 per tape. Well, C equals 5/4 times 5, and C equals 25/4, or essentially 6.25. And remember that we are again in millions of tapes, so that we can label properly and not misrepresent our numbers. Hope that helps you with direct variation. Good luck and have fun.